Thank you. 1 minus alpha times 100% confidence interval for such. So again, when you say alpha, those are the outskirts of the confidence interval for such. So first of all, we need to get the point estimate, and that is the mean of your sample data. We can also get the standard deviation of the sample data. In some cases, it is given. In some cases, it needs to be computed for using StatCrunch and some other computing devices. So as you may notice in here, there are the formulas for the high bound and low bound. High bound x plus a t value, which we have mentioned yesterday with the formula, right? Sample mean minus population mean all over sample standard deviation over sample size, square root of sample size, with n minus 1 degrees of freedom. And later we're going to see what that means. And yes, that's C alpha over 2 because that's split into 2. S over square root of n. So let us now read in here in problems 13 to 16 how we're gonna work on this one, okay? Let's read this one first. Brett, please. Thank you. Numbers 13 to 16.
In problems 13 to 16, determine the point estimate of the population mean and margin of error for each confidence interval.
Thank you. Let's consider answering number. Okay, it's up to us what we want to work for in here. Choose a number in here, Braden. Let's go ahead. Yeah. What number do you want us to work on? 13 or 15, 14, 15, 16? 13, thank you. So can you read number 13 in here, please? Thank you. So first of all, we can illustrate this one. Okay, so we're gonna consider it to be a normal distribution. Again, with the assumption that the sample size is big enough, all right, by central limit theorem and law of large numbers. If the sample size is big enough, then first we can assume that it's a normal distribution regardless of the shape of the population where it came from. And the law of large numbers telling us that whatever the sample mean is that we're gonna get, it should be as expected. In short, it should be definitely related to the population mean, and the same with the standard error, okay? That the sample standard error will approach the value of the population standard error, standard deviation as well, okay? So again, those two are important for the assumption of normal distribution and expected values and standard deviations, right? What are those again? Central limit theorem and law of
large numbers.
Large numbers. Very good, right? So those are the two accompanying theorems, principles for us. Well, where's the low bound? Here it is, 18. And where's the high bound? Here it is, 24. So that means to get the point estimate, where should that be? At the midpoint, right? At the center. So that means, how do we get this one? What we call our point estimate x bar, equal to how much? What do you do with 18 and 24 to get the point estimate? Robbie? Add divided by 2. Very good, right? In short, just get the average, right? Or the mean, okay? All right, calculator, what's that gonna be? 18 plus 24 all over 2. Anyone who got the answer for that? Angelina? Robbie? 21, thank you. Sorry for that. Okay. 21. There we go. X bar, again, that is our what we call point estimate. Yeah. What else do we need for this one? Okay, Giselle, what did you say here? After the point estimate, what else do we need? Margin of error, all right, for this confidence interval. So the margin of error is either you get the difference between the high bound and the point estimate, or the point estimate and the low bound. Either of those will be fine because again, we have assumed that this is a normal distribution curve anyways, right? So in short, what do you think is the margin of error for this one, okay?
3.
Yes, answer, Mason, 3. Very good, right? So the margin of error is 3. However, the width is double that. So when you say the width, however, this is the width.
6.
Okay, which is 6. You double the margin of error, then that will be the width. Okay, questions, guys? And again, that will comprise our confidence interval. Any questions regarding that? The rest in here will be basically StatCrunch work. Let us analyze this one in here, okay? Something with sleeping. Okay. Right, let's analyze this number 22 and see how we can work on this one, okay? Juliana, right? Okay, go ahead. Let's now read number 22. Thank you.
The 90% confidence interval of the number of hours that full-time college students sleep during a weekday is lower bound 7.8 hours and upper bound 8.8 hours. Which of the following represents a reasonable interpretation of the result? For those that are not reasonable, explain it well.
Okay, so what do you think in here? What would be a good interpretation of that? Well, first of all, let us visualize first, right? So visualizing this one, we have our normal curve. It didn't say anything about the point estimate, however, but the low and the high bound were given to be as follows, 7.8 to 8.8 hours, okay? And this in here will comprise how much? 90% level of confidence, that interval, right? Of the low bound and the high bound. So, which among those will give you the correct interpretation of such? Hint. What is 90%?
The confidence interval?
Confidence interval, okay? So that's
Oh.
giving you a hint, right? It is the one. Confidence interval, right? So that means which among these will be a good interpretation of such. And please do consider this as a statement because you always need to have this interpretation on your confidence interval. Both for population proportion and population, right? So which among those will be correct?
I think D.
Letter D, we are 90% confident that the mean hours of sleep of full-time college students during a weekday, did it say during a weekday? Yes, it says during a weekday. Very good. Is between 7.8 and 8.8 because in letter B, yes, it also says something about a confident, but it says in here any day of the week, so that means that includes the weekend, right? But yes, letter D is correct. Let us read this once again all together. Go ahead. We are
90% confident that the mean hours of sleep that full-time college students get during a weekday is between 7.
Thank you. Okay, so again, confidence interval must have the term confident. Okay, not probability, confident. Okay, also it must have the proper interpretation of the level of measurement. Okay, if it says within the day, within the week, any day within the week, you do it. But in here, it just says weekday, so you just do the weekday. When you say weekday, Mason, what are weekdays?
Monday through Friday.
Very good, right? Monday to Friday, right? So it excludes Saturday, Sunday. Cool? Right? So again, this one is just basically interpreting it, but definitely not computing for anything. But anyway, let's compute for something. Okay, let us read in here number 19 and see how we can use our StatCrunch to compute for this confidence intervals necessary for us. Okay, Kalina, let's go ahead and read number 19, please. Thank you.
A simple image of both size and response.
Continue, please. A.
Construct a 95% confidence interval for student the sample size is 35.
Thank you. Okay, so let's do that one for letter A. Once again, what is our given? 18.4, what is that?
The population.
Okay, sample mean, X bar. Very good, right? But again, not for the population, but for the sample mean. Okay, X bar, and 4.5 is our S, our sample standard deviation. Okay. Now, what is our sample size in here for letter A? Tiff, did it say what's the sample size for letter A? 35. Very good. Okay. Now, what can you say with the 35? And what can you say about these two key terms, right? It being a random sample and it sample size being 35. What can you say then? Anyone? OB, go ahead.
It's greater than 30, so it's normal. So normal distribution.
Very good. So we can assume normal distribution because the sample size is big enough to assume normal distribution. Very good. And at the same time, first place, it did a random sampling procedure, right? Not a non-random sampling, not convenient sampling, but simple random sampling. Okay, so again, hence we can assume a normal distribution. Okay, again, because the sample size is big enough to assume normal distribution regardless of the shape of the population. Get it? Okay, and what is that law again or theorem? Starts with letter C.
Central limit theorem.
Very good, right? Thank you. You know, it's a good, it's almost there, right? You got the central line, right, okay? You know what I can think of, what comes to mind when you talk about central limit theorem? I think of Charlotte, right? You see? Charlotte, CLT, central limit theorem, you see? Right? I just discovered yesterday from like this social media thing that Charlotte is one of the cities that, you know, has one of the lower cost of living, right? Well, actually, our area in here is relative to the rest of the, you know, urban communities in the entire United States. We are on the lowest in terms of cost of living, right? Which is, you know, a good thing for us, and hopefully not too many people will move in here to, you know, share with the advantages of living in here, right? Anyway, is that right? Yeah, because other than that, well, if a lot of rich people who live in here because they feel like it's lower cost of living, then it's gonna make it higher, and you know, what about us, right?
Yeah.
Okay, anyway, going back in here, so this is what, 18.4 as our X bar, and our sample standard deviation S is equal to 4.5. And again, we can assume normal distribution for such, right? So we need to know this confidence interval, right? What's the lower limit and the upper limit to make this, how much? 95% confidence interval, right? And again, with N being equal to 35. Okay, so this time we're gonna use a StatCrunch for this. And here it is, guys. Let's do this. Let's go to StatCrunch first, okay? So, go here, let's go to our Blackboard, let's go to our StatCrunch. So please do open your StatCrunch and see how we can work on this one. All right. You know what, I'm gonna open 9.2 so that later we can answer maybe 1 or 2 questions from 9.2 as well. With that confidence or interval for population mean. Oh yes, it should be in there already, right? You know, from yesterday, the confidence interval for population proportion. Yeah. It should be in there, those applications. Those are from yesterday, right? Well, let's click on this 9.2 homework, and again, later we're gonna answer some of these. But for now, our goal is to click in here, go to StatCrunch, and answer this question. Our existing question, right? So go to stats. Okay. Yesterday we did proportion, right? Today we're doing what? T, right? We're doing T. So click on the T statistics. Okay, T stats. How many samples are we considering? One sample, right? It's just one sample. Okay. So after that, we don't need to get the sample size. We just need to get the what? The summary, right? The confidence interval. So click on with summary. If it's raw data, you're gonna click on data. But in here, we are not given raw data. We are given the X bar, S, and N already. That's a summarized value. Okay. So click on summary and basically plug in everything in there. Okay. So as simple as that. Okay. Let's put this. I'm gonna just move this down and put it in here. Okay. What's the sample mean again? 18.4, right? And again, that is also the point estimate for the population proportion, okay? What is the sample standard deviation? 4.5, very good. What is the sample size? 35. And again, we have assumed it to be a normally distributed because it is big enough, more than 30, okay? Now, we're going to click on confidence interval because that's what's being asked. And what confidence interval are we talking about? 95% confidence interval, right? So just plug in everything that is given. So in here, it already says 0.95 anyway, so that's fine. You can click on that show critical value if you want to or not, and click on confidence interval plot so that you have like a basis for such. And let us click on compute. There we go. Did I click it? All right. Okay, as quick as that one, it already gave us the lower and upper limit for as such. So with that being said, what does it mean? The sample mean is already given to be 18.4. The degree of freedom, we say the degree of freedom is what? 1 less than the sample size, right? So as you may notice in here, the degree of freedom is 34. So if n is 35, then that means, let's call it df, degree of freedom is 34. Because later we're going to use that one to like see what t value corresponds to that, okay? So what's the lower limit, by the way? 16.85, okay? So I'm going to put in here 16.885, right? You know what? Since this is 1 decimal place, this might be 1 decimal place as well. I'm just going to put in here 16.9, okay? There we go. Oops. Okay. And what's the upper limit? 19.9, okay? So as simple as that. We got the lower and upper limit as follows, okay? Now if we click on the right side, it's gonna give you an idea of how it looks like. So as you may notice in here, that's how it looks like from such. Now what does it mean? Oops. Okay, this means as follows, okay? That this is your point estimate. And what's your point estimate? 18.4, okay? So as you may notice, that's 18.4 X bar. Now this and that will be the upper and lower bounds. If you draw a normal curve like that, the upper bound turned out to be what? What's in there? 19.9. So as you may notice, that's near 20, almost 20, 19.9. And the lower bound in here is somewhere here. And what is that? It says 16.9. So that's the lower bound, and this is the upper bound, and you can treat it as your 95% confidence interval plot. We good? Okay. Yes. It's just that in here, it doesn't draw like a normal distribution curve for such. Okay. But again, since the sample size is big enough for that anyway, then you can do that. Okay. Now, Mr. Deal, how do we do this one with without StatCrunch? Okay, so without a StatCrunch, we're gonna use that formula. Okay, T of what? Okay, so in this case, so this is what I'm gonna do. I'm gonna go back, go to the problem, and analyze this one without StatCrunch, and we're gonna use this T distribution as well. Okay, and let's see what we do from there. Okay. Okay, going back in here, if you have a 95% confidence interval, then that is your what? 100% of what? 1 minus alpha. Okay, that's your confidence interval. So in short in here, how do you get your alpha then? In short, the alpha is just basically the complement of 95%, right? Which is what? 5%. So your alpha is 5%. But since it's split into 2, right? Then that means your alpha over 2 is how much?
2.5%.
2.5 per tail. Okay? So the left end tail is 2.5% and the right end tail is 2.5%. And again, what's our degree of freedom? We said it's 34. Okay? So with that being said, let me X this out and check on our T table. So we're going to use our T table now to see where is our alpha 0.025 with degree freedom 34. So look in here now. Look in here. So as you may notice in here, that is to the right. Okay, so what T alpha over 2 should we consider for such? Again, we want a 0.025 because it was split into 2, right? So 0.025. And your degree of freedom is 35 minus 1. Okay, so that's 34. Where's that 34? So let's look in there. Where is that? Okay, 2.032. Get it? So that is our, what's this again? This is our T for 0.025. Again, that's our alpha over 2 with degree of freedom 34. And how much is that? 2.032. Okay. Now, using this formula, let's see how we're gonna get that value a while ago, okay? So doing the high bound, what is this then? What's our x bar again a while ago? 18.4, thank you. So that's high bound will be what? 18.4 plus, what's our T alpha over 2? We said 2.032. Okay. Times, what's your sample standard deviation? Did it give us a sample standard deviation a while ago? 4 point what?
4.5.
5, thank you. 4.5. All over square root of n. And what's your n? 35. Okay. Now let's verify. What's that gonna be on our calculator? Okay. Let's verify. Let's go to decimals. At least you know you have an idea on how to do this one without the stat crunch. Okay. And what is that? 18.4 plus 2.032. And again, we got that one from the T table. Times our sample standard deviation is 4.5 over square root of 35. Okay. And what did we get? 19.9. Which what we got a while ago for the upper bound, right? For the lower bound, what you're gonna do? As simple as this. Just copy that one, plug it in here, change the plus to what? Minus. As simple as that, right? Okay, so this is your 16.85 or 16.9 a while ago. So again, either you do StatCrunch or you use our T table, you're gonna get the answer either way. Questions? Okay. Now, let us consider now, since we are already on Pearson, let's answer question number 1. In Pearson, it says in here, and let's read this question in here. Okay, this 9.2 question number 1. Let's read it. Caroline, go ahead, please. Yeah.
Determine the t-value in each of the cases.
Find the t-value.
Find the t-value such that the area in the right tail is 0.02 with 29 degrees of freedom.
Thank you. So let's analyze that one. Well, visualize this one first, right? So visualizing this one, we got it as such, right? So this one and to the right, okay? The area to the right tail is how much? 0.02, okay? Okay, now what is that t value in here? To the right, okay? And again, what's your DF? Degree of freedom is 29, okay? So let's verify our T-table, so you know what, we can click this T-table in here, or our existing T-table. Either of those will be fine. Okay, let's look in here. As you may notice, that's area to the right already. So we're just looking at what? 0.02. Did it say 0.02? 0.02, thank you. Right? So 0.02 area in the right tail. So that's your, where's that? What's the column? This 0.02 column. And degree of freedom is what? 29. Okay, so that means I don't need to less 1 anymore because that's already the degree of freedom anyway, right? And what's the answer? 2.15, right? So 20, what did it say? 29. Okay, and that's 2.15 for that. Okay. In short, if the degree of freedom is 29, what is the sample size?
30.
30. Very good. Okay. Again, because the sample size less 1 is your degree of freedom. And again, if it's 30, then we can definitely assume a normal distribution. Okay. What did we get? 2.15. Okay, so it's plugged in there. 3 decimal places it says in here. But then that'll be fine. 2.15. 0. Okay, can you do that one letter B? Area to the right is 0.01 with 23 degrees of freedom. Look into your T table. BF 23, right tail 0.01. Okay, look in here. 0.01, where is that? Okay. Third column on the right. Okay, is that 0.01? Okay. And 23 degree of freedom. Okay, what did you get? On your end, guys. Again, you don't need to less 1 anymore because this is DF already, right? So 23 DF, 0.01. Right tail as well. Okay. 1.3. 0.01. I think you're looking at 0.1.
2.5.
2.5. 0, 0. There we go. Right? Okay. So again, don't confuse the 0.1 with the 0.01, guys. Right? There's like a 10 times difference. Anyway, what did I get? 2.5. 2.5, 0, 0. Or just 2.5 would be fine. Mr. Deal, what if it's to the left? Okay, let's read this one, letter C. Okay? Andrew, let's read letter C. Yeah, find the t value.
Find the t-value such that the area left of the t-value is 0.05 with 16 degrees of freedom.
Hint. What's the hint again?
Use symmetry.
Thank you. So again, we know that one of the properties of t-distribution is that it is symmetric, right? In short, what's happening to the right part of it is the same happening to the left. It's just that it should be what? Negative instead. Okay, so that's the only difference for those. And again, that's one of the properties of t-distribution. Whatever's happening to the right is symmetric to the left. But again, to the left, it's basically just negative of that. But anyway, let's look at that. So in short, we just look at what? A 0.05 t-value with 16 degrees of freedom to the right and just make it negative because of symmetry. Okay, so as simple as that. Let's verify in here. 16.05. Okay, let's look in here. So 0.05 and 16 degrees of freedom. And what did we get? 1.746. Negative of that. 1.746. Okay. You get the same thing, guys? Okay. 0.05 degree 16. 1.74. Negative because it's to the left, alright? So let's put it in here as such. Negative 1 point, did I say what? 746? Okay, so anyway, oh, the last one in here. Find the critical t value that corresponds to 70% confidence, assuming 9 degrees of freedom. A.
I have a question on B. Mine asked me to find the right tail, which is find the t value such that the area in the right tail is 0.15.
Yeah, so definitely yours might be different from mine. It's just that mine is 0.01. So in your case, you look at 0.1015 and you're gonna get your own answer as well. So again, each of our items are different. I'm just answering what's written on my end. Okay?
This one doesn't have all of them for some reason.
Get it, guys? Okay. So again, we have different values, but again, the process are basically the same. Basically, definitely, I'm gonna help you out with yours as well. Let's read the last one in here. Letter D. Let's see how we can work on this. Emma, go ahead, please. Letter D.
Find the triple D value that corresponds to 70% confidence instead of 12%.
Thank you. Okay, so how do we do this? Well, first of all, let's draw this one first, right? Okay, so here it is. When you say 70% level of confidence, right? So this is 70%. So in short, the right and the left will be how much each? 15. Very good, right? Because 100 minus 70 is 30%. Divided by 2, that means this is 15% or 0.15. And also in here is the same 0.15. Very good. Tip. Good analysis for that. And again, the degree of freedom in here is given to be 9. Okay. In short, what's the sample size? 10. Very good. Again, if it's 10, we can use t-test still, like this one, provided that the population shape is assumed to be normally distributed. Okay. If that's not the case, what do? You do the QQ plot that we did with 7.3, which you compare and see the linear regression. If it's above the critical value of that correlation, then we can assume normal distribution, all right? So if you can recall the 7.3, refer to that one, okay? But anyway, in here, let's see. We're looking at what? 0.15, okay? Because 15% on the right, 15% on the left. DF, 9, okay? Oh, let's verify. Go back in here. DF9, 0.15. So if we look in here, green, okay, 0.15, DF9, 1.100, okay? Again, yours is different than mine, okay, but the same analysis, okay? Got it? So, what is that? 1.1. So let's put it in there. Again, that will be 1.1 to the right and to the left, okay? So let's put in here 1.1. I might be putting in the plus or minus as well because that's the same on the right and left. Okay. Oh, okay. Looks like it accepted the answer. Okay. Get it? What we did? But again, to the left, it's negative, right? Okay, so this is what I'm looking for. This is number 11, and the goal of number 11 is basically the reverse. What now if you want how much of a sample size you need to achieve a level of confidence for such a population mean, right? Let's read this one in here. This is number 11, question number 11, okay? Mia, let's read this one in here. A doctor wants to estimate. You might be too far from there. Mason, can you sit from there? Thank you.
The doctor wants to estimate the mean HDL cholesterol of all 20 to 29-year-old females. How many subjects are needed to estimate the mean HDL cholesterol within 4 points with 99% confidence, assuming S equals 19.7 based on the earlier studies. Suppose the doctor would be content with 95% confidence. How does this decrease in confidence affect the sample size required?
Well, anyway, before we answer that one, let's answer this one first, right? Because it says in here, how many subjects does it need for a 99% confidence interval? Okay, so what do we have in here? What is 19.7?
The sample.
Sample, standard deviation. Very good, right? So that's the standard deviation of the sample, 19.7. But it says in here, within 4 points, the mean HDL cholesterol within 4 points. Okay, how many subjects are needed to estimate the mean HDL cholesterol within 4 points with 99% confidence, assuming 19.7, S equals 19.7, I would assume that is the sample standard deviation, but it didn't give us anything about the mean. Did it give us anything about the mean in here? Or the point estimate?
No, but if you click on the,
Yeah, if you go on the critical value table, it's,
Mm.
it gives you the critical value for 99%.
Okay. Let's see in here. Because I'm assuming that in this case, let's verify this one, okay? I need something with the mean value already to, you know what, let me change the question first. I'm looking for something that needs a mean for such. Let's see, you might be able to work on this one, okay? Let's see. If I click on StatCrunch, okay, because what our goal is to get that sample size given the width, okay? Let's see how we can do that one. If we click on Stat, this one is T statistics still, right? One sample, and again, we need the what? A sample size given the width. Well, at least we got the width, which is how much? It says 4, did it say 4? Right? Okay. So, if we click in here, what's the confidence interval that we need? 99%. Okay, so if I put what? 0.99. Oh, that's correct. It doesn't need the mean anyway, or the point estimate, right? And what's the standard deviation? It says to be how much? Okay. This is the 19.7, right? Standard deviation is 19.7. And the width, again, it says in here, based from the given problem, it says within 4 points, right? Cholesterol within 4 points. So we say within 4 points, and that means, does that mean 4 points to the right and 4 points to the left? Which means like 8 points all in all. Let's verify, okay? So, where is that? Okay, here we go. If I click in here and make it what? 8 points, right? If it's 4 points to the right and 4 points to the left as the width, let's see what sample size we're gonna get out of this, okay? It gave us how much? 165 as a sample size, okay? Again, that is if you are having that 4 points, assuming that 4 points is the margin of error, okay? We double that one for the width, and that will be 8, okay? Okay, but in here, it basically changes 7.99 once again, simply because you want the sample size to be what? An integer value, right? Let's verify. Because if not 8, then we can choose 4. So let's see. 165. Let's put it in here. Let's see. Okay. So.
What did you click on to get to that?
Alright, so here it is. Let's go ahead and summarize what we did with that one, right? So again, what we want in here is a what? Sample size needed for the width. Now, since it says within 4 points, and that means that's the margin of error, right? So that means the width is what? 4, another 4 on the right and on the left, so that's 8, okay? Basically the same as our sample size from yesterday on population proportion, but for mean instead. Okay, so what do we do? Let's go to StatCrunch, go to here, all right? You go to stats, okay? This is T, stats. Let's go to one sample. We want to know the sample size with the width because it says how many subjects are needed to achieve that 99% level of confidence. So make this 99%. Standard deviation is given to be how much again? 19.7. Very good. And in here, since that's 4 as a margin of error, the width is double that size. That's 8. And again, that will change depending on an integer value for the sample size. So it's nearest that width, however. So it changed to 7.99, which is basically still 8, approximately, and with a sample size of 165. Okay. Now on the second option, it says 95% confidence interval. Let's see what's going to happen. If we lessen the confidence interval from 99 to 95, what will we get? 96. Okay, so your sample size gets what? Bigger or smaller? Smaller, right? So in short, the smaller your confidence interval is, what's going to happen to the sample size needed? It decreases as well. Are we good? Got it? Very good. Very good, guys, with what we did with that. And I think this one is good already for that. And yeah, that's it. That's basically the third question, right? Let's read this third question just to wrap up what we did with this, okay? Robbie, go ahead, please. Yeah. How does the decrease in confidence affect the sample size required? Answer?
Decreases.
8. Very good, right? So, correct, right? That lowering the confidence interval also lowers the sample size needed for such. Questions, guys, with what we did? All right. So at this point, oh yeah, let's cut that one out in there already, guys. Thank you, and at least.